Well, hello there, everyone, and it is I, Baby Crone, on my last day of school. And guess what? On my last day of school, I had to do a presentation in astronomy. And you know, I teach astrology, astronomy, science, the esoteric, the world around us, after all. And I figured, since I made a presentation and I do teach on this channel, why not share my presentation here with you guys today? Well, let's just begin. So today I'm going to be talking about Planet 9, or as my title says, the search for the new ninth planet. So right here, you're probably wondering, what is Planet 9? Well, it has a cool nickname, Planet X, and it is a hypothetical planet, of course. It does not exist. It is only mathematically figured out, which is very interesting because I'm just like, wow, you can really, well, getting ahead of myself in the presentation. So a little bit about Planet 9. Here in this picture, as I said, it does not exist. So this is just an artist's rendition of the information that I will be presenting here with you guys today. What this planet could possibly look like. And as you see, it has a bluish tint like Uranus and Neptune, and that is because of something I'll be talking about later in the video. However, Pluto, as you see right here, used to be the ninth planet. However, it is no longer a planet and is considered a dwarf planet, and we will be talking about other dwarf planets that are affected by this hypothetical Planet 9. And we're going to be learning a little bit more about our solar system and what's going on in space and in our neighborhood, literally. So just to bring you guys forward a little bit about astronomy. Mercury, Venus, Earth, and Mars are the inner planets, as they call it in astrology. But in astronomy, it's called the terrestrial planets, and they're rocky planets that are made of rock mostly, and therefore because they're made of rock, they're much smaller and much heavier, and therefore able to stay near and closer to the sun. However, the outer planets, as astrology, or the gas giants, astronomy calls it, is Jupiter, Saturn, Uranus, Neptune, not Pluto, and Planet 9. So, a little bit about the gas giants. Because they're farther out, they don't receive as much sun, so therefore Planet 9 is very hard to detect, because the farther you get away from sun, think about it, the farther you are away from a light source, the dimmer it seems and the darker it gets. Well, that light source is also a source of heat, so the farther you are away from your heat source, the colder you get. So therefore, this is the conditions on Planet 9. And there are Kuiper belt objects, really asteroids. There are 2 asteroid belts. And the one we're going to be talking about today is called the Kuiper belt. And that is between Neptune and Planet 9. And that's also where Pluto just happens to reside, in the Kuiper belt. That's why it's been demoted as a dwarf planet. And then the other asteroid belt is literally the asteroid belt, which is between Mars and Jupiter, probably what we're all familiar with and where we think all asteroids are. However, a thing about Kuiper belt asteroids, they can also be comets. So this is where a lot of comets, and like Halley's Comet, for example, originates from. They come from Kuiper belt, very far out in the distance where we won't see them for hundreds and thousands of years. That's how far out they are. So think and imagine how cold and dark it is where Planet 9 is. So a little bit of history about Planet 9. Well, these 3 dwarf planets, as I said I'm going to be talking about, were affected by a mysterious gravitational force. Now, they've been affected for many years by this mysterious force. However, as I said, their orbits takes years and years and years and years to go. So therefore, just perfect time in history for these 3 planets, dwarf planets, to line up in a way that it looked, instead of just looking like a dot moving normally, because It has nothing else with it to see the difference. But now we have 3 objects moving this weird way, and astronomers were just like, why are they moving like that? That's interesting. We didn't notice that before, because all 3 planets weren't there for it to be that noticeable. It's easier to notice 3 weird moving objects compared to 1 moving object. And that is, and because of that, in 2015, 2 Caltech University students, Mike Brown and Konstantin Bagatin, discovered this mysterious planet and dubbed it Planet 9. So, as I talked about, Jovian means Jupiter-like, which means you're a big gas giant. Just think of a big Jupiter's like a balloon, just up with air. That's what Jovian planets basically are. And these qualifications that are listed on this page are for any type of planet. So all these planets have to go through these criterias. But because they've already known how big the planet is, it's as big as Jupiter. So not as big, but very Jupiter-like in size. So therefore it's going to have qualities like Jupiter. And as you saw in the previous picture, well, really, Jupiter has rings. Saturn's rings are just distinct. Neptune and Uranus also have rings. So therefore, theoretically, Planet 9 should also have rings. But it just happens to be that Saturn, for some reason, has more distinct, noticeable rings compared to the other gas giants. And to quickly talk about on this page a little bit, because I realized I did not explain this picture. This picture shows you Planet 9 in its orbit. This dot right here is the Sun. And literally all the other planets in the solar system are all around this Sun right here. But this is just how far out Planet 9 is in comparison. And these purple lines right here represent all the different types of Kuiper Belt objects, asteroids, dwarf planets, smaller objects in the space. Those are all orbiting in these weird ellipses or orbits, and it's mostly affected by Planet 9 when they start crossing Planet 9's gravitational energy field, which is its orbit. And as you see right here, a couple of them do cross around here, and that just so happens to be very close for us to see from the Sun. However, Planet 9's all the way over here, so it's really hard to detect Planet 9 because it's just so far away. Imagine trying to find a needle like 200,000 miles away from you. Okay, imagine this. Try finding a needle a football field away from you. It's impossible to see that needle. That's basically how we're trying to find Planet 9. So far away we can't see it, and we're just like, we think you're here. By math, we think you're here. We're just trying to find you. We don't know how we're going to find you. We're just going to try to find you because we know you should be here because we have these planets, these orange orbit planets, having their orbits altered in a weird way, that there has to be something else contributing to it. So if Planet 9 is real, it has to pass these qualifications. Does it orbit a sun? Yes. Is it large enough that it has a spherical shape? Well, if you're Jupiter-like, Jupiter is spherical, so therefore, yes, it's spherical. Okay. Does it align with the elliptic plane? Meaning, does it align in order with how all the other planets orbit in respect to the Sun? No, it does not. That's the only qualification it does not pass. Is it the only celestial body in its orbit, which means is it the only planet in its lane, basically? And if it's not, that means it doesn't have enough gravitational influence to dominate a specific space. So therefore, this planet, if it is real, it And we might have evidence to suggest that it is, because there are objects being affected if it crosses Planet Nine's lane. So check. And if it's Jupiter, like, it should have theoretically moons, several moons, like more than 2. Several moons, and have rings as well. So what do scientists know? Well, theoretically it should be 5 to 10 times the mass of the Earth, times that by 10, the max size they think it is. And this is how big it is. E means 10. And 10 is just like a base for like really big numbers. This is like, I'm not sure, 25 is like over a billion. So it orbits theoretically 20 times the distance of Neptune. Neptune's distance is 30 AU, which is basically mileage for planets. It's not really a mile. It's way more than a mile. It's everything, of course, is based off of Earth's perspective. So 1 AU is based off of how far the Earth is from the sun. So therefore, the Earth is 1 AU away from the sun. And so theoretically, the planet should be 600 AU away from the sun. That's huge. That's almost like 1 mile compared to 600 miles. Imagine that. And because of that, because as I said, the farther you are away from the planet, from the sun, the longer you take to orbit. So therefore, to complete 1 year or 1 orbit rotation around the sun could be 10 to 20 years. And its eccentricity, which means basically the way that the orbit is shaped, is it circular, is it elongated, is about 0.022 to 0.6, and the highest you can go is 1, and the lowest you can go is 0. Binary code. So here's the planet that could possibly exist. Keiju for short, discovered in 2018. As you see in this picture right here, this is what the orbit, the ecliptic plane is. And as you see in this picture over here, this blue line represents the ecliptic plane, and this red line represents Planet 9. And as you see in this picture right here, Planet 9 is the yellow line. And it's very tilted. And there's this planet that was discovered that has this weird orbit. They're just like, why is it orbiting like this? And then they're just like, because this is 3 years after Planet 9 was hypothesized. They're just like, well, given its region in space, we think this might be because of Planet 9. So it's clearing objects that could be orbiting in its path, because it has to cross eventually in some way. And to give you, this is the size of the Earth, if you think about it. And if you want to compare it to how big the Earth is, well, 5 Earth masses. This is depending on different types of content. So because it's a gas giant, it is mostly made of hydrogen and helium. So therefore, a gas giant that is 5 Earth masses is going to be about this big in comparison to the Earth. So they have all this information. Planet 9 has to be real, right? Well, it's only based on mathematical modeling, but if it does exist, they do believe that other objects have an orbital resonance, which means they match up or harmonize. So it's like a ratio. If you think about it, for every 2 cookies, I give you $1. So that's how it is. So for every 2 orbits, this Planet 9 makes around the sun. Okay, no, for every 1 orbit, Planet 9 makes around the sun. Another planet, a dwarf planet, made 2 orbits in comparison, and it would have met like this and like this during their orbits, in a sense. They have 2 times where they're approach and close to each other. That's what makes them a resonance. It's like basically when you're on a track and running, and you pass the person that you're running, and then you guys meet up again, and you high-five each other. That's basically your orbital resonance, and every time you meet up and do this, you have a resonance with each other, and that means your energies are bouncing off of each other. And so this would make sense, because if that is the case, that means this planet is large enough to dominate its lane and able to affect other orbits of other planets or dwarf planets. And because of where it is in the solar system, it also makes sense based off of the formation of the solar system, because it is a gas giant, and gas giants should be farther out from the sun, so therefore it makes sense that it's there. But it doesn't make sense that it's that far out. It just seems weird. Why is it that far out? Well, that energy is interacting with each other. Maybe it was much farther in, and it just happened to bump up against Jupiter or Saturn, and their energies just boom ejected it and like flung it all the way out, and it was like ah, and then it just landed where it was, and it was like, this is much stable for me. And it's something, and there is proof of that. Neptune, our last planet, that happened to Neptune. The order used to be, I'm only starting from gas giants: Jupiter, Saturn, Neptune, Uranus. But Neptune was booted because it must have gotten too close to Saturn and pushed it out, and it felt its balance there. So now it's Jupiter, Saturn, Uranus, Neptune. So if that makes sense, so therefore Planet 9 could possibly be real. It matches with the formation of the solar system. Check. So here are some key points. Because it is so big, 5 Earth masses, think of 5 Earths all bunched up together. So therefore it is very dense. So therefore it makes sense, because denser objects are formed out in the farther out regions of the solar system, because that's where a lot of the first material from the solar system is located. That's why a lot of comets are just so dense compared to Earth rocks, yet they feel like a feather when you're holding them. It's because of how the material is compact and dense inside. So this is probably how dense Planet 9 is. And as I talked about, intensity represents the light. The light is inversely, meaning distance. Instead of distance, you're dividing by distance. Squared. So therefore, the farther out you get from the sun, the lower the light is. And that's why Planet 9 might be just extremely dark, because it's so cold it can't even radiate thermal energy to be picked up, and it can't reflect light back because it's not having any light hit it. So after that, this E represents eccentricity that I was talking about, and the A and B represents how the circle is aligned. And if you rearrange this equation to solve for A, you can then plug in A to this value right here. A represents the distance from the sun, and from that, this P will tell you the period it takes for a planet to make one revolution around the sun based off of its distance. So this is showing you a little bit of how they do math to find out this information about the planets that we can't see, touch, or even visit. And also, that was a little bit of information about that. So some characteristics about Jovian planets. As you see, Jupiter, Saturn, Uranus, Neptune, Pluto, they all have categories to them. Everything past Jupiter, it's so cold that water is ice. And everything past Neptune, everything is so cold that now methane is ice. Because a lot of the gas giants past Neptune are made out of methane, and the gas giants, Jupiter, Saturn, Uranus. No, Jupiter and Saturn are made out of hydrogen and helium, but Uranus and Neptune are made out of methane. And so based off of this chart right here, 5 Earth masses, this is where according to this article, they believe 5 Earth masses at a radius 2.9 is the right estimate for Planet 9. So if that's the case, then that means the temperature Planet 9 gives off is 42 Kelvin. So if we go right here, 42 Kelvin is maybe right about here. So if we go there, it's maybe about the same temperature as Pluto, maybe a little bit less cooler than Pluto, and that's because of its distance, as we was talking about. And in this image right here, talking about how possibly it doesn't make sense for a giant gas planet to form this far out, because if this is where like Uranus and Neptune is, then off this page, so far off, you can't even imagine, is where planet 9 is. So therefore, there is no gas there. So why is there a gas giant out there? Well, as we said earlier, it must have formed around here and then got poof right out. So there's a search for planet 9. Planet 9 was made, they're going to be searching for planet 9 next year. That's going to be fun. And in next year, they're going to be using a telescope called the Vera Rubin telescope. It was originally called the LSST, as you will see in the next slide. And a way that they're going to try to find this planet, because it's so cold, is to look through the cosmic microwave background, which is basically the first ever light that ever existed since the time our universe formed. So that means everything you see right here, even though we can't pick it up through a telescope, it exists. So somewhere in this picture, if planet 9 exists, it's one of these colors. It's probably one of the darker colors because, well, if it's about 42 Kelvin, it's maybe, never mind, it's in a different scale. So it's really cold. And there are difficulties for trying to search for a planet that is this far, regardless if it's in our solar system or outside our system, called exoplanets, because they're so far away. Actually, exoplanets might be a little bit easier because they're orbiting around their star. However, we live in our solar system and we just happen to live close to our star. So we're looking at things that aren't near our star in our solar system, and we call those distant planets. So it's hard to search for distant planets in our solar system because we're already so close to our light source. So how we try to find distant planets? Well, here's another reason why it's hard. Gravity, space, and time is like a fabric. Think of a trampoline. If you sit something heavy on a trampoline, it bends. So if planet 9 is this dense, which it is because it's affecting the orbits of other planets, dwarf planets, then therefore if we try to see a planet that's near it, we're thinking we're looking directly ahead, but actually we're just looking on, it's actually like right there to us in comparison. And because of that, that is so hard trying to figure out, because it's so dark. Imagine if this was black. That would appear to be a black hole to you, wouldn't it? So scientists theoretically think this might be a black hole in our center of our not in the center of our solar system, but in the far outskirts of our solar system. But that is not real. They do not believe that 100%, not even 50%, not even 20%, because really, mathematically, if there was a black hole right there after all these centuries, we would have been swallowed up because it would have just gathered up so much mass from eating. Anyway, so it's not that. And as I said, the LSST is a telescope that they're planning on using next year to catch all the different varieties that they think this planet can emit. The red line represents if it can illuminate light and it's easy to pick up. The blue line represents if it emits so little light it's almost impossible to detect. And if it's just right based off of their calculations where they think it just might be about 4 radii, not like 2 radii, and then in diameter this way, and it's weird, and about 5 Earth masses, then it should be theoretically this green line. But as you see, these different bars represent the capabilities these telescopes are able to reach. So a lot of these telescopes aren't able to reach most of these lines, but the LSST is the most one that's capable for reading this line. So because of that, that is what they're going to be using next year, and hopefully for that, they're going to be able to find it. And with that being said, I hope you guys, here is my works cited. And with that being said, I hope you guys enjoy my presentation, and hopefully in 2023 and in the next few years we hear about a new 9th planet, because if it's really there, and as I showed you the picture, that means we truly do have a new 9th planet, and that means how many other planets are farther out there that we just can't see yet, because our technology just haven't grown and advanced yet. So with that being said, I hope you guys enjoyed this presentation. You guys learned something new, and I will see you guys later. Bye!